Hello, 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 and welcome back to another episode of Kerbal Space Programming. Kevin here, and Bob is on his way back from the moon. He has spent the better part of a day finishing up doing a bunch of surveys from above different biomes above the moon, and he has set a maneuver node that will eject him from the sphere of influence of the moon and return him back to Kerbal. So yes, we're popping out here. We can look at the map view, and we have managed to get ourselves into a return trajectory, which is great. And the idea is that we were planning to upload a script that would point the craft retrograde, do the staging, all that stuff, and make sure that we deploy the parachutes at a safe altitude. So he is coming home with a bounty of science, having collected it from the various instruments, which of course will be re-entering the atmosphere in a slightly more explosive fashion. Now, of course, yes, okay, there we go. Flipping around. Okay, that looked dangerous for a second, but we have a periapsis that is going to bring us down into the atmosphere, and Bob has suddenly had a rather creative idea. Rather than relying on another script, he has decided to keep his antennas disabled and will instead set up his own return plan without consulting anybody at KSC. So Bob's cunning plan is to actually set up another maneuver node. So because we've got this craft set up to execute these things when he toggles the RCS, he's going to add a maneuver when we're still outside of the atmosphere to burn off the remaining fuel. And because we have Kerbal Engineer installed, he knows exactly how much Delta V is remaining in his craft. So he can bring this down. And of course, we don't want to go quite so steep, but we can go ahead and tweak this using the radial stuff and just try and make sure that we have a burn that uses up the majority of our fuel so that we slow down our velocity. And he's going to go ahead and let the ship remotely explicitly execute that maneuver. And there we go. We see the craft is beginning its burn, which will burn up almost all of the remaining fuel because we set it up for just below the Delta V that is left remaining in the craft. So we're going ahead, we're burning, and of course the question on everyone at KSC's minds is, why has Bob not contacted us, and what on earth is going to happen if we are not able to upload a reasonable descent script? But we can see the Delta V available is trickling down as we complete out that maneuver, and of course we've left a little bit of a margin just because, we want to make sure that the CPU doesn't get caught up in anything crazy. But the idea here is that we should end up with a reasonable descent speed because we're not coming down directly from the moon. We're burning off some of that remaining velocity. And now, having turned off the lights, Bob is preparing another crazy maneuver. Now, you remember in the previous episode, we had not set up an abort script. He is actually going to leverage the abort script that we have added since. Now, this is going to fire there we go. It's going to fire the decoupler and arm the parachute, and the parachute has been tweaked so that it will not deploy until we reach a safe altitude. So he is going to free fall his way back to Kerbal. And there we see Bob is coming down on his completely unpowered descent. Now, the idea is that if we actually had some commands for that, for the CPU to run, it could actually point us in an exact retrograde orbit, but it does seem that the heat shield is managing to cover this stuff. It's just a question of whether or not that slight deviation from the surface retrograde vector is going to mean that enough heat can reach the parachute, at which point Bob will be in serious peril. But he is, of course, doing some science on his way down, trying to maximize the value of his mission, doing everything possible. And yeah, it looks like we're still coming down pretty darn fast, though. Our speed is dropping, our altitude is dropping faster. Bob, this may have been a bit of a mistake. This craft was not designed to ensure that we would point exactly against the surface. So, okay, but there we go. We are slowing down reasonably. And we can see, yeah, we've used very little of the ablative heat shield. We can turn on the lights because we've got plenty of electricity remaining now for the remainder of our descent. And it looks like Bob's crazy strategy has saved us down at the KSC from having to write, I don't know, maybe 2 or 3 lines of actual code. And with a safe deployment, Bob is coming down, finishing up his mission. And there we go, a safe touchdown with the lights brightly highlighting the terrain. Bob will go ahead and hop out and see if there's any remaining science to be had from this biome, though I believe this is all stuff that we sort of retrieved before because it overlaps with stuff that's near the Space Center. But nonetheless, just testing, making sure that we can get as much as possible out of this mission. All right, well, There we go. We'll board anyway because we apparently already have that. Can we do a crew report? Nope. All right. It is time to recover Bob. And look at that. 620 something science. Tons and tons of science from all around the moon, and high over the moon and low over the moon, recovering some of the funds, but obviously not most of them because we've only come back with a small amount of the craft. And Bob has gained an experience point. I don't quite remember what it does, but okay. Now we are able to unlock some more stuff. We're going to unlock electronics, which gives us the accelerometer and the Communitron 88. This should mean that we can reach Duna and Eve with our satellites once we put something out there. There's also some TAC fuel stuff, or TAC life support stuff rather, and we can get the scriptable control system, the smaller version, which plays much more nicely with the small probes. So we'll grab that, and let's see, we can get some additional stuff. We could get another one of these higher up things, but I think, let's see, oh, that could be, the command modules could be nice, but I think we should probably stick and grab some of the 90 level things. There's heavy rocketry and advanced construction, which gives better decouplers, and aerodynamics, which gives stuff that we're not really using. RCS could be useful. And then there's okay, so the inline stabilizer and the RCS stuff, that could be helpful for docking and miniaturization, which doesn't give us a ton. So I think we're going to grab, we're going to get the small rockets. There we go. And we're just shy of enough to unlock one more, which is frustrating because there's one more that I think we ought to get. But after a quick jaunt out to the launch pad and the runway to test our seismic accelerometer, we've gathered enough science to unlock one further node, and I've decided to unlock the procedural fairing. So we've got that there. We've got a payload on the top of here, sort of peeking out. You'll notice I've also added the engine lights mod back in because I think that is just really, really cool, being able to see the flamey flicker of the lights on the fins of our rocket. But yes, we are running this under time acceleration because this is a rather complex craft, though it is about the same weight as the previous mission, and so we're able to use the exact same launch vehicle. We're just bringing it up under the same ascent profile, same stuff that we've done a bunch of times already, bringing this thing up, getting it circularized and orbiting, and I'm very excited about this. This is a secret payload that we're about to reveal as soon as this gets up and does its circularization. Come on, get up there, get that speed up, do all your stuff, and then coast, of course, to apoapsis, and there we go. We have a secret payload inside here, and we're extending a whole bunch of solar panels, and you can see now that these are little replacement Omnisats. So we've got 4 different probes stacked here. They've all got their own batteries, they've got their own solar panels, and you can see they also have their own CPU stuff. That little dot on the top of the probe core is the smaller version of the KOS CPU. And the idea is that we're going to launch these into a much more stable orbit than our previous Omnisat network. You see, we actually have all 4 of these CPUs here. From the top to the bottom, we've got a whole bunch of complex staging. We've also added a whole bunch of tags. You can actually right-click any part in the vehicle assembly building with KOS installed and add a tag to it so you can refer to it specifically. Because if we were trying to figure out the name for a particular, if we were trying to figure out, well, give me the CPU, it's not going to know which one we're talking about. So we're boosting ourselves up into a transfer orbit. We've calculated what our orbit is going to be. So we want to put these about 800 kilometers away, or at an altitude of 800 kilometers, and that means that we want the apoapsis for this launch vehicle to be at approximately that, but we're going to make sure that its periapsis is not 800. We want to make sure that it's 75% that of the orbital period, so that by the time it makes one complete revolution, it has gotten about 90 degrees ahead of the probe that it has launched. So we're going ahead and boosting ourselves up and getting up and up and up. We can see the sun coming up over the horizon, and there we go. Okay, we are at least in orbit, and now it's just a question of waiting because we are going significantly higher than mere orbital velocity, boosting ourselves up, and we can see the moon out there. And I really, really like this engine lights mod and the way, especially how it flickers off of all of these solar panels. Now you will notice that because as soon as we jettison these fairings, this thing did get a fair bit unstable, but because we're thrusting at reasonable rates, and there's not a ton coming out of this vacuum optimized engine, it seems to be relatively okay. But I think, okay, so we're just finishing up here, getting ourselves up into a high orbit and waiting for it. There we go. Transfer orbit achieved. Wonderful. We've got this thing ready to start launching probes, and we can take a look here. And yes, we've called this the boss. And so we're going lower than these omnisets, which are so out of alignment. High enough that we'll still be able to, that all of these will still be able to reach each other, but lower than the existing omniset network, because they are a little bit toward the maximum of the viable range for these things. So we are warping ahead till we get to apoapsis, so we can let this thing go ahead and circularize. Come on, get up there, using the KSP Warp 2 stuff. And yes, now it's trying to orient itself toward prograde, because it's going to go ahead and complete its launch orbit, get itself to 75% of what we want it to be at. And we're going to let the probes actually finish up their circularization once we launch them. So, and yes, the cooked steering is being weird as ever, rotating it around a whole bunch of axes, but we finally managed to get it up there. And we're still about a minute away, so we'll warp ahead just a little bit. I set these up so that all of the actions are going to happen 20 seconds before apoapsis. We could have done something more exact, but really what we care about is that the orbital periods of these probes end up being the same, not necessarily whether their apoapsis and periapsis are completely identical, because as long as their orbital periods are very close to the same, then they're not going to drift out of alignment, or at least after completing one orbit, they will be the same distance from each other than they were before. So, yes, and now we are using kind of the same technique that we used in the past for reducing our throttle, unfortunately, because we've got this set up to try and slow down while we're getting to the semi-major axis that we want. It already thinks that we're most of the way there, and so we are thrusting with very little thrust, and I've thrown physical time acceleration on just to try and speed this up, because this does take a while to complete. So let's see, and yeah, you can see if on the nav ball that we are wobbling a fair amount, which is a little bit worrisome. If we deviate too much, there is a possibility that this craft could get unstable and that we could lose a probe before we intend to. But I believe what we're targeting right now is a periapsis of a little over 300 kilometers, so we are creeping up there. And man, yeah, even with physical time warp, this is taking a ridiculously long amount of time. Now, it should be noted that despite the fact that KSP does put these things on rails, that is, that the apoapsis and periapsis theoretically remain stable infinitely as long as you don't hit the atmosphere. This isn't the case with real spacecraft and real satellites. They do need to perform minor corrections because there is a tiny fraction of atmosphere out there, and they need to compensate for that. And then, of course, then there are things like solar winds and just tiny little fluctuations that can, over time, build up to cause an orbit to decay or expand or whatever. KSP does not model that, but it does have a little bit of an issue in that because they are saving things as numbers that can be a little bit imprecise, the result is that even if we get these into a perfect orbit, there's not an actual way to represent these as a perfect orbit. So if we were to, we could edit the save file to make these things permanently stable, but we shouldn't require much station keeping. Now, granted, the omnisets that we put in the past were already a fair bit off from each other, as we can see by those orbits. But yes, even with perfect placement, we will need to look at some station upkeep. The idea, though, is that we should only have to look at the probe upkeep maybe once a year or so. So we should have quite a while before we have to worry about this again. And more than that, though, I'm very much looking forward to just killing off those existing omnisats because, oh man, they are terrible. But having achieved our launch orbit, we can go ahead and warp around again until we get to apoapsis. So this first, we were just making sure that we circularize because we want to actually launch these things right at apoapsis, and we were a bit past apoapsis by the time we completed our circularization. Again, weren't particularly concerned about making sure that the apoapsis remains in the same place. We're just trying to make sure that the orbital period is approximately what it needs to be so that these things end up equally spaced. And yes, we are approaching, get it down to 20 seconds or so. And come on, do your stuff. Come on, you can do it. Just waiting, and there we go. All right, releasing the probe, and it is off. And you'll see we are leaving 2 decouplers and an engine shroud in space there, which is unfortunate, but this thing is now taking itself away, and it is going to go ahead and finish up its own circularization, boosting itself up till the average of the apoapsis and the periapsis are 800 kilometers. So it's going and going and going. And of course, it's going slow enough that even if we look at kind of there's not much in the way of engine trails. We can look, it's puffing out in short little bursts, which I suppose is kind of a realistic way of visualizing it, though, at least as far as KSB is concerned, we are thrusting constantly with just a very, very low thrust. And of course, with some judicious time warping, we should be able to get this thing up to its stable orbit. Now, its apoapsis and its periapsis are not going to be 800 kilometers, exactly, because we are a little bit past apoapsis. See, we're burning it behind us, and it's going to rise, and we can track that over time as these go up. But as long as the average of those is 800 kilometers, and the average is consistent across all of the probes, we will remain stable. And there we go. Boom. Alrighty, we have our first new boss satellite, the Better Orbital Space Satellite, placed in its orbit. So we'll switch back to the boss and let it warp around and do more stuff. But I think in the meantime, it's probably good to take a look at some of the scripts that we're using to manage this. Alrighty, so here we are in our launch script, and this is all pretty standard fare, very similar to what we did in previous episodes. The only change here is that we are first checking if our ship's status is pre-launch before we do all of our launch stuff. And the reason for this is that once the probe gets past a certain threshold, the main launcher craft is going to get out of range, and that means when we switch back to it, it is going to reboot. So we want to make sure that it doesn't try and ascend after it has already ascended, because we want to watch the probe and let it do its circularization and then jump back to this craft. So we've got if ship status pre-launch, we've got our ascent profile, which is all very similar. Let's see, the only thing that's different here is that, yes, when we wait till we get to apoapsis, and then instead of circularizing, we're going to boost to our transfer orbit. And we're going to lock the throttle to 1 and subtract the percentage of the way there that we are. And until our apoapsis is 800 kilometers, we'll burn out if we have to, lock the throttle to 0. So that's going to get us up to that transfer orbit that we saw. Now all we need to do is finish our circularization for our launch orbit. We'll lock the steering to prograde, wait until we're at apoapsis, and now we're going to track the ship's semi-major axis, and then this target altitude that we want our semi-major axis to be. Now, the important thing to keep in mind and remember is that the semi-major axis, which is the average of the apoapsis and the periapsis, when we get it from the ship's orbit, we're actually getting that from the center of Kerbal, not the altitude. So when we're comparing those values, we need to make sure that we add the radius of Kerbal to our altitude. So if you're 20 kilometers off sea level, you're actually 20 kilometers plus the radius of Kerbal as far as your real apoapsis and it goes. So we'll go ahead, we'll lock the throttle to that. We'll wait until it is greater than or equal to this target value. So this is the altitude that I calculated that we know we want. There's a formula for calculating the time, your orbital period, and that's T equals 2 pi times the square root of semi-major axis cubed divided by, divided by mu. Yes, the mu of the body that you're orbiting. And that's complex. It was much easier to just go ahead and calculate it twice for these two. So we figured out, well, the first one is such and such. Our semi-major axis is 800 kilometers, then we get a certain time we want to wait. We want our semi-major axis this time to be 75%, or we want our orbital period to be 75% of that, so that when we come around again, we've actually gone a little bit faster. We'll lock the throttle to 0 and say that our launch orbit is achieved. And this is all that is going to happen, this will only happen if we're going directly from pre-launch. Otherwise, when this thing boots up, it'll jump ahead to this next stuff. And this next stuff is pretty simple. We're just going to say if ship parts titled, and then we put in the name of the smaller CPU part, and we're going to check the length of that. We're going to say if it's more than 0, meaning there's still a probe attached, then we're going to wait in orbit. So we're going to wait for our ETA to apoapsis to be greater than 30. Then we're going to wait until it's less than 20. And the reason that we're doing this is that otherwise, if this thing were to happen to reboot, then it is entirely possible that we would launch all 4 of them right away. So we'll wait until we make sure that we are past the apoapsis, and then we'll wait in orbit, and then notify that we're releasing probe, and then stage. And that is all that this is going to do. So when we boot this up the second time after this is already launched, it is just going to run this bit. Now, the one important thing, though, is that because we need this to be able to launch multiple times, we can't just transmit this as an update script like we've done in the past. So we actually have to we're going to upload this and name it the startup.ks file. That way, anytime that the CPU boots, it'll go ahead and run through this logic. So our actual update script for the Launchcraft is pretty darn simple. We're going to say copy boss.launch.ks from the archive, and then we're just going to rename it startup.ks. And the way that our boot file works is that if it gets an update, it'll go ahead and run it, and then it will wait for new instructions and it will reboot. And if it finds that startup.ks file, which we've just made it, well then that's perfect. It'll go ahead and run it. So the actual upload or the actual update is really, really simple. Now, the last thing that we need to set up is the actual script for the probes themselves. Let's take a look at that. Alrighty, so the Boss satellite boot script. Now, the thing is that we are actually going to set this as the boot script for all of those small probes because they have a smaller disk size, and that means that we don't necessarily want to include the full boot script that we've written for the majority of our craft. So this is going to be the only thing that this craft has on it. So that means we also have to handle all of the stuff that we would have handled automatically in our regular boot script. So we're going to set the ship control pilot main throttle to 0 so that it doesn't try throttling up whenever it's disabled. And now all this is going to do is it's going to wait until there's no ship part tagged Boss launcher. What I've gone ahead and done is in the VAB, I've taken the main CPU from the launch vehicle and given it a tag called Boss launcher. So this will wait until there is no such thing on the ship. That way it knows, okay, well, I must have detached and I can go ahead and execute stuff. Now we're going to check to see if our semi-major axis is less than 700 kilometers plus the radius. Well, then we know we've got a boost, right? So we'll lock our steering to prograde, wait 10, throttle up until it is 800 kilometers, do this whole, throttling down thing so we don't overshoot, and then we'll lock the throttle to 0. So this will handle the circularization. Once we're done with that, we're going to grab the Communitron, get the RT antenna module, and this is a little bit important. I discovered a little small issue. If you try to run an event on a module that exists but doesn't correspond to the right state. For example, if the antenna was already turned on and we tried to activate it again, that's going to cause an error. So what we're going to do is we're going to get the status of the Communitron first and make sure that it's off. So if it's off, then we'll go ahead and activate it and turn on the lights. Now all this is going to do is it's going to say wait until it has a connection and switch to 0 and list all the files. And this is doing that kind of file detection stuff that we've written into our regular boot script. What it's effectively doing is checking if there is a file named what this CPU's part tag name is, plus init.ks. So I've gone through and I've named these, I think we named them boss1. So it's going to check for boss1.init.ks. And if it finds that, it'll go ahead and run it. Now, this will wait 10 seconds and reboot. So what this is going to do is it's going to go, okay, if until we have actually discarded the launch vehicle, so until this is staged, it's going to, when this boots up, it'll wait for that. But once that's the case, then this can go ahead and reboot every 10 seconds and constantly check for a boss1.init or boss2.init or boss3.init. I suppose the last thing worth explaining is that you can actually get the part of the current CPU. So we have, get parts named and get parts tagged, but if there's a command called core, and we can say core part, and that'll give us the part of the CPU unit that is currently executing, which is an easy way to go, I'm referring to me, please. So that's how we go ahead and grab the tag for the current CPU. That way we can upload the same script to all 4 different probes and just give them different tag names. And now we know if we were ever to upload boss1.init.ks, then it'll go ahead and pick that up. And of course, then we can go ahead and say, well, clear out this entire file and set up some new instructions and do all of that stuff. So, alrighty, it is time to take a look. I think our last probe is finishing its circularization. Let's jump over and see how it's going. And there we go. Yes, we have a nice little rectangle of these satellites, and we can take a look. This thing is just wrapping up. Come on, turn on. There we go. Our last satellite in the network is done. So now it is time to simply deorbit a whole bunch of stuff. Our old satellites, our launch vehicle, all of these coming crashing down, re-entering the atmosphere. Wonderful. Really excited to have that terrible network dead for once and for all. And of course the solar panels and stuff flying off. All of these things managing to get through the atmosphere but crashing down, which will leave us in a better place for future episodes. So I will hope to see you then, and have a good rest of your whatever unit of time. I will see you soon. Cheers.